Hey there, geometry. A little bright behind me. Sorry. Had to plug in my computer and move my chair. We are in Unit 2, Lesson 13. We're still talking about parallelograms and proofs with parallelograms. I'm going to come over here and mess with the Notice and Wonder on GeoGebra. Okay, this is not the printout you have, but you can access this through the link I put in Google Classroom. Okay, so here's parallelogram ABCD and rectangle EFGH. What do you notice? What do you wonder? So the one over here is a parallelogram, and here is a rectangle. Now we know that a rectangle is a parallelogram, but a parallelogram is not necessarily a rectangle. What do we notice? What do we wonder? We can actually drag some things around. My opposite sides stay congruent. Okay, my opposite sides also stay parallel. If we had measurements, we could show that the diagonals bisect each other also. Here, I can't change my angles, can I? Let's see if I can move it this way too. Yep, I can change everything else, but I can't change the angles. The diagonal angles. They are stuck at 90 degrees. So that's what I notice. I do wonder about the angle, like where the diagonals intersect, what angle they're at. I know it's movable. Here, I can change them. Here, I don't believe that angle's changing. Well, the Y angle, maybe not, but the this angle maybe not, but this angle, yes, when I move it like that. Same here, I don't know. It looks like it's just dilation, like it's getting bigger and smaller. Interesting. All right, so let's move on to 13.2. The diagonals of a parallelogram. Conjecture. Diagonals of a parallelogram bisect each other. So that's our guess. Now we have to prove it. So use the tools available to convince yourself the conjecture is true. So let us do that. The diagonals of a parallelogram bisect each other. GeoGebra. I'm going to construct this with you watching so you see it's not impossible to construct. More. So let me make a line. And then I'm going to make a parallel line. I'm going to copy that down. I have C, so let's go ahead and do a line through here. And then I'm going to make a parallel line to that. And I'm going to make it through B. All right. Mark that intersection, which I need more because I need points. All right, I'm now going to do something that seems very silly, but I'm going to make segments over each one of these things so that I can hide the lines. Remember, segments are pieces of a line with distinct endpoints, and lines go forever in both directions. This is just going to look a lot cleaner to me. See? So these are parallelograms, and I think no matter what I do, they stay parallelograms because that's how I constructed it. All right, I'm going to undo that so I can see it. Okay, now let's go ahead and construct the bisectors. So I need a segment from A to D and a segment from B to C. I'm going to mark that intersection, and then I'm going to measure. This is not how you prove, by the way. I'm just really curious. Yeah. Very cool. Okay. Now I'm going back to your curriculum to see what it actually asked me to do. Use the tools available to convince yourself the conjecture is true. Check. We did that, right? Convince your partner that the conjecture is true for any parallelogram. Can the two of you think of different ways to convince each other? If you and I were working together, I can't think of another way to convince each other. except drawing it and measuring it. Can I measure with a circle? I really like measuring with a circle. And that's something that is way more accurate. If I did a compass from here to there, and then I moved that to here, oh no, to here, it works, okay? So DE is the radius of circle D, and AE is the radius of circle A, and those circles are congruent. I can do the same thing with the other side. So, ooh, and another cool thing, look at that circle where it is now at center E. Diagonal CB is the diameter. I forgot the word. Isn't that funny? Diameter. Radius? Radius. Okay, so we just used another way to convince ourselves. Diameter, which is very cool. I don't want to leave those drawings on there, though. What information is needed to prove the diagonals of a parallelogram bisect each other? Let's look at their response, because I think we just did that, but let's look at what they say. We are trying to prove that the sides are congruent, so we probably need to use the side angle side congruence theorem. Okay, so here's what I need to do. I need to go ahead and hide some things or delete them. I'm going to copy this picture over so that we can write a proof. Okay, let's go ahead and screenshot this. Notice I'm not pausing it so you can see all the things I'm doing. Copy. Go over to notes because this is where I've been doing everything. We're in here. Let's just try to paste it lasted. I'm going to try to, can I drag this up? Why can't I drag this up? What's that mean? I want to be able to draw on it. All right, I'm going to pause this. All right, that time it worked. I don't know why. So we are going to write a proof about this. So I constructed a parallelogram, and what we know about a parallelogram is those are congruent. Oh, sorry, parallel. Those are parallel. And those are congruent, and those are congruent. All right, that's what we know. So I have lots of sides being congruent. I'm trying to prove that, let's do it in red. I'm trying to prove that this is congruent and that's congruent. So how are we going to do that? Okay, I could deal with the whole, let's do a highlighter because I can erase it later. In the past, when dealing with parallelograms, we have done a lot of proving that this triangle and this triangle are congruent. I'm having issues with my pen. See, I took my pen off. It's still going. I don't know what happened there. But that's what we've been doing in the past with parallelograms. Okay, that's not going to work for today. Now we need to actually just talk about either this little triangle and this little triangle, or we can do an or, this little triangle and this little triangle, okay? Because those triangles have the sides that we're trying to prove. So let's get rid of those. So actually, I'm going to highlight, I'm going to mess with these two triangles, okay? And let's write a proof. I'm going to go back to my pen, and we're going to say that ABCD is a parallelogram. Given. Now I can say that AB is parallel to CD, and let's just go ahead and say it. AC is parallel to BD. Definition of parallelogram, like that shorthand, parallelogram. Parallelogram. Okay. We also know that AB is congruent to CD, and AC is congruent to BD. Definition of parallelogram. And those are all the things I've marked so far. Now let's talk about the angles. If I can say this angle is congruent to this angle, because they, when the lines are parallel and it's cut by a transversal, the alternate interior angles are congruent. So I can say that angle ABC is congruent to angle ABC DCB, because when two parallel lines are cut by a transversal, alternate interior angles are congruent. I'm out of room already. This is sad. Okay, so now I'm going to go for these two angles. Angle, to move my head. B80 is congruent to angle BAD CDA. And it's actually for the same reason. Right? Now I have angle, side, angle. Okay, angle, side, angle. So I can say those two triangles are congruent. So triangle ABC is congruent to triangle ABE is congruent to triangle DCE. Because of angle, side, angle. Now we're trying to prove bisect those diagonals have bisected each other. So we're essentially done. I can say AE equals EB. CPCTC, CPCTC. I can also say that BE equals EC. CPCTC. All right, and we're done. Okay, so this was my statements and reasons. Now we could have gone through the exact same steps by dealing with this triangle and this triangle. Okay, the exact same steps. Either one would have worked. That's it. Was that section 2? Yes, it was. All right, let's see what's next. All right, so this one says work backwards to prove. Okay, so given ABCD is a parallelogram with AB parallel to CD and AB parallel to BC, diagonal AC is congruent to diagonal BD. So this is actually a rectangle. So those diagonals are congruent. Okay, so we're proving that it's a rectangle. Angles A, B, C, and D are right angles. So with your partner, you will work backwards from the statement to the proof until you feel confident that you can prove ABCD as a rectangle using only the given information. We're not going to start with this as well. I would know that ABCD is a rectangle if I knew, I'm going to say one angle is, sorry, dog barking. If I knew one of the angles was 90 degrees, then I would know all of them are. But let's make sure that's the way they want us to go. Yep, if I knew the angles were right angles, right? And the next thing says, take turns saying this sentence, I would know what my partner said if I knew whatever, okay? I would know angle ABC and DCB were right angles if I knew they were congruent. I would know ABC and DCB or right angles if I knew they were congruent. All right, now let's get that highlighter out of there. We've got all the given things. So this is given, that is given, and diagonal AC is congruent to BD. I'm going to mark those with red. So AC is congruent to BD. And this is congruent to that, definition of parallelogram. This is congruent to this, definition of parallelogram. So let's change colors just because it's fun. I now can say that triangle, let's see, A, B, D is congruent to triangle CDB because of side, side, side. So I just did this triangle and that triangle, okay? So, oh no, yep, side, 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 because it said in the given that they are congruent. Okay. Now we can keep on going in green. I can also say that triangle, we can go the other way, ABC is congruent to triangle CDA because of side, side, side. Now let's go with the angles. We're going to do a lot of CP, If we're in the yellow one, let's say that angle A is congruent to angle C. CP, Angle B is congruent to angle D. CP, I don't think I can go angle A to angle D yet, because they're not in the same triangle. Ooh, got it. Okay, let me erase this. This is the way we need to go. Pink triangle with yellow triangle. Okay, do you see how they overlap? All right, and we can do that because of this. I'm going to mark in red again. We know that these diagonals are congruent, and that's congruent, and that's congruent. So I'm actually going to erase. I just don't have enough space to keep on going with that. All right, let's change to blue. Triangle ACD is congruent to triangle ACD BBC because of side, side, side. Now angle D is congruent to angle C because of CPCTC. I shouldn't have erased what I did in green. In some lands, I would start this video over, but I'm not going to. Now let's go here. We already did this one. Triangle A, B, D is congruent to triangle ABB, CDB. Side, side, side. Now we can say angle A is congruent to angle C, CPC2C. Okay, now let me show you this. Okay, we know those two are congruent, and we know those two are congruent. So I can actually say that angle A is congruent to angle D because of substitution. And we said right here, early on, I would know that angle ABC and DCB were right angles if I knew they were congruent. I would know angle, ABC. Okay, we can't do that one though. BAD and ADC were right angles if I knew they were congruent. Because, and I've been calling that angle A and angle D. So we learned that the inside the parallel lines against the transversal, those are consecutive. So we know that angle A plus angle D is 180. And since they're equal, I can say that 2 of angle A is 180, so 1 angle A is 90. Therefore, 1 angle D is 90. And once we know one of them is 90 degrees, we can go around the whole parallelogram or the rectangle like we have been and say all of them are 90 degrees. Okay? So that was tough. That was tough. And it really was splitting the rectangle up into, I guess, what we see here. And I like how they did those lines. That being one triangle, and let's do green. This being one triangle. It was the only way to do it, because then we can deal with the angles. I can do C is equal to D, and then I can go A is equal to D. Yeah. Okay, that was tough. Good work.